Okay, so are you guys seeing my screen? Just let me know. You could write your chats. You could write the chats and let me know. I'm just sending an email. Okay, so are you guys seeing my screen? Just let me know. I had it on multiple instances, that's why I had to change that from there. Just let me know in the chats if you guys could hear me and everything is proper. So we don't have any problems, after that. Let me just quickly send this email to the Codecademy people with virtual event ticket, event um, details. Okay, event. Actually, I had to write an email related to this event, which is Introduction to Machine Learning. I think it's new email, Codecademy audience, people with virtual event ticket. Um, yeah, and this one we are now live. So let me just send this link quickly. Oh, awesome. You guys could see me. Perfect. So let me just quickly send this YouTube live stream link so that those other people could join in as well. Um, so this will take just a second. Okay, so let me just get this link. Seems like we're doing great, I guess. Link quickly. Okay, and link. Okay, schedule and send. Send this immediately. Send now. Oh, okay. We we are live. Schedule. Send this immediately. Send now. Okay, so I think we're good and we could start right now. Okay, so welcome everybody. Just let me know in the chat if you guys could hear everything and see if everything is perfect. Are you familiar with machine learning? Is anyone familiar with machine learning? Anything they have done uh, regarding machine learning or anything? Just let me know in the chat if you know anything that's there to know about that. Just let me know if those chats roll in, and then I could start over here related to this stuff. Okay. Seems like you could quickly, send your chats. Let me know just quickly, whatever you know, so I could just get started. I believe everything is working properly. Roll in, and then I could start over here related to this stuff. Okay. Seems like you could quickly, send your chats. Let me know just quickly. There's a sort of delay I've seen, but I think that won't give us a big problem. So I'm assuming that everything is going correctly. So I'm just going to start right away. Welcome everybody to our first live stream of this month, and probably this year. This is the first live stream for the Coding Cleverly chapter on Codecademy, now on YouTube as well. And this is going to be a chapter about everything you need to know about programming and everything. There's the chapter link. Uh, awesome. Nice to know, Stephen. So this is basically the first event for this entire year, and I really wanted to do this a little earlier, but no problem. So this event is about machine learning, and this is going to be a beginner intro level event where we're basically going to go from the ground up. Like we have an idea, like no one knows about machine learning, so we're just going to say what this is and everything. So machine learning is basically like a branch of science where basically what you do is you have a machine and you want to make the machine give outputs of some real world examples, and you want the machine to accurately predict something, and you have to feed the machine beforehand, and then whenever you ask the machine to do something, or whenever you ask the machine a question, it will learn from its previous models or training that you gave, and according to that training, it will provide a result. So let me just show you some cool little pictures about machine learning. So machine learning sample. Let me just see what's there on the internet, or maybe process. Let's see. I think that would be a little better. Okay, so there's this process of machine learning life cycle. I guess there are so many ones, but I guess the one that we need is something pretty simple. And I guess this one is okay. So what's happening here is that um, basically, this is ingest, organize, clean, and prepare, test and validate, deploy, manage, and track, machine learning model, data munging, data prep, and data wrangling. Okay, there's a lot of big lingo over here, but I don't want to, complicate things. I just want to say that it's basically like a model, and what you do is you train that model. It's a dummy. It's like it doesn't know anything. So you train it and you stuff it in with some knowledge, what you have or what you find, and you just basically train it constantly, day in and day out. Just keep on training it until it reaches to some point where you are confident that it could be now tested. These are two parts in the machine learning process. One is called the training, and the other is called the testing. The training phase is where you basically train the whole model. You assume that the model knows nothing, so you train it constantly. But once the model is trained, then you go with the testing phase. And the testing phase is pretty much just like the test of the whole process, the training process. And this is where you want your results. So whatever you trained, you're gonna ask it results, and you're gonna assume that according to what they ask, I mean, what you said before, now we'll have to predict something which is appropriate. Some really big examples of machine learning applications that are built and based on this is like the YouTube algorithm, search algorithm that is constantly being worked, and this is where like basically this is using machine learning, the YouTube algorithm, and it defines where the when you're watching a video, it determines what type of video was good enough, and it constantly shows you more videos related to your likings, and that's how machine learning is used there. Other than that, there's machine learning in different other applications. One of the biggest ones is ChatGPT, which is a big trend right now. Everyone's using it, and I guess it's one of the biggest applications there ever existed, and this just recently announced back later this before I mean last year, in the end of the last year. So now what we're gonna do is we're gonna basically introduce machine learning, and I basically have this Discord server, and if I could open up the Discord server, this is the official Coding Cleverly Discord server, and I post useful resources and everything in here. So what you all have to do is join this Discord server, and I sent some useful resources here. And this is the file that you need to download. This is called the practical machine learning.zip file. So just go to the Discord server. If you can't find the invite link, I'll send it in the chat. So let me just quickly send the invite link. Um, so the one where you could download it is basically go to the channel. So just type in coding. Um, Wait a minute. So yeah, coding. Oh, there you go. So this is you can see the live stream is going on here. Go to the Discord server. If you can't find the invite link, and what we're gonna do is we're gonna go here, and you will see this is the Discord server invite link. And here I'm just gonna copy this, and I'm just gonna paste it right in the YouTube live place. I'm really sorry if I'm going a little slow. This is actually the first time doing a live stream here, so Uh, I'm I'm learning, but hopefully we will improve throughout the year. And this is the first live stream I'm doing on YouTube. I've done live streams back in your Light Hall, Zoom, Google Meet. I use so many platforms, even Bevy. But this is my first time on YouTube. But hopefully we'll improve with the passage of time and assume you guys should all join this server. So join. the Discord server and download uh, the zip file. Come on, zip file. There you go. Okay, I have completed an intro. There you go. Thanks, Pyrobyte. Hi, man. Okay, so now that we've done everything, and I believe people are in joining in, just uh, just put a thumbs up here once you download this. So I believe everyone's joining. So I could see you guys basically join in the general, and I could see things popping up here. So I see you guys joining in. So what all you have to do is go to the place where the useful resources, and yeah, awesome. Just download this. Perfect. So I could know. Now it says a potential dangerous download. Trust me, this is safe. This is a clean file, and just download it in your machine or whatever. I have it downloaded, but I'm just re-downloading it. And once you're done, what you're gonna do is you're gonna open it up. I put it in my desktop. It's pretty easy to get. And the other thing I assume that you guys already have is Jupyter Notebook. This is Jupyter Notebook. This is the other version. It's basically downloaded using the Anaconda prompt, and this is the Anaconda Navigator. So this is the whole thing. Let me just open it up. Um, so it's gonna open up in a moment. It's a little big bundle of packages and features that you would like for data science and machine learning. And one of the packages that exist here is Jupyter Notebook right here. And then there's so many other things like Jupyter Lab, Qt Console, Spider, VS Code. But all what we need is Jupyter Notebook. So I did recommend this back in my last live stream. What we did, I think it was the last month on December, or it was one before. Uh, and I recommended my students and everyone to download Anaconda prompt. Just quickly, let me plug a charger in. I just remembered that we are out of battery. Okay, good. Now, what we're going to do is download this and launch it. So that's all we have to do. If you can't find this Anaconda install button, what you would want to do is go to um, Anaconda, come on, Anaconda prompt, Anaconda Navigator, I guess, Anaconda Navigator download. And according to what your operating system is, mine is Windows, so it's just going to detect by itself what operating system you're using, and it will download it for Windows. So you can see it determined my operating system, and it will give me a Python version. I don't have to install Python in this. It's just gubs. I mean, I don't have to install Python independently. Go to python.org. For those of you who have Python installed, it's okay. You just have another copy of it. So what you do is basically click on this download button, and then you accept this executable, and then you follow the wizard and install it safely. And once you install it, you will see the Anaconda navigator here, what I showed. But what we need is the Anaconda prompt. So the Anaconda prompt is something like this. It's just like a command line. And I'm not going into detail on the installation and everything. If you want to if you want to know this in more detail, you could also let me know in the chats. Maybe we could make a video about it on the YouTube channel or whatever. We could explain it in the Discord server. But right now, my main focus is trying to let you guys know how to get started with machine learning. So what we're going to do is now here we're going to, so this is the Anaconda prompt. What we type in is Jupyter, and then we say notebook. That's all we have to say. And we press enter. And what happens is that Jupyter Notebook opens up. And this is the screen of Jupyter Notebook. And you can see that there is these folders over here. This is my root directory, and I have to go and explore where my file folder was, which was called Practical Machine Learning. All right, so this is in my desktop. You could see. Ignore that. So let me just delete that. So this is in my Practical Machine Learning on my desktop. So I have to go there. So you can see that it was opened here. So I go to my, I think in OneDrive, and then it's in my desktop. Then it's in my Practical Machine Learning, should be over here. Practical Machine Learning, and then there's this thing. There's a folder, there's a file, a JPEG, and then there's a supervised workflow.svg. Um, about this is that if I look at the folder and show you what's in the contents, there's this folder and you'll see this thing. So there's this picture of a flower, and there's a petal, and then a sepal, and then there's this IPyNB file, and then there's supervised machine learning workflow. It's just a SVG file. So all we have to do is open up this IPyNB file, and we're not going to open it up in VS Code or any editor. We're going to open it up in Jupyter Notebook. So the simplest way to do is go back to your Jupyter Notebook environment and just click on this IPyNB file. And then once you click on it, it opens up a new extension, new tab, and this is the first notebook that we need. Okay, so this is the Jupyter Notebook, and you can see over here, rename notebook. So I would say getting hyphen started, getting started. I'm just gonna say this, and I'm just gonna press enter. Now I changed the name of my notebook file, and you can see over here, last checkpoint was made on 1/19 and 2023. These are the check marks, sorry, that were made recently, and it's just happening over and over automatically. And this is the Python version that is being used. And I told you like I didn't need to know. Now this is practical machine learning walkthrough and scikit-learn training and testing model. This is the diagram that I have to explain right now. But before everything, I would have to tell you guys that Python is important to know. If you know a little bit of Python, then this session will be highly productive for you. For those of you who aren't familiar with Python syntax or anything, then I would recommend trying to, just a little bit know Python, but I'll try to explain this in the simplest way possible so that you will feel like you already you already know everything. So that's my actual goal here. Um, Enough with all of the talking. Let's get straight to business. Here we have scikit-learn training and testing model. Now, in machine learning, like I told you, that there's two different processes. One is the training phase and one is the testing phase. Training phase is the one that comes before. So you could see in this diagram, we have a training data, and then there's this model, or like I told you, that dummy thing that has no idea what's going on. It's just a stupid machine that has nothing. And what you do is basically train that machine, and you're training it with data, and you give labels. Now there's different type of training. There's called supervised, unsupervised machine training, machine learning. But the one that we're looking at here is with data and labels. Now, what do you mean by data and labels? Now, if I go back here and say um, supervised machine learning, okay. So what is it? It says over here, are known as supervised machine learning is a subcategory of machine learning and artificial. It is defined by use of labeled data sets to train algorithms that is classified data to predict outcomes accurately. So basically, it uses labels. And if I could give you an example of a supervised machine learning, and look at this, is pretty cool. Now what we have here is we have input raw data and we have the output. I guess we're going to be using, we basically throw in so much data, but we give labels to that data too. So what we say is that you can see over here, there's a bunch of fruits. There's an apple, a mango, and then there's a pear. And what we say are the labels. We say to the machine that we throw in all these fruits, but we also tell the machine that the red one is called an apple, the green one is called the pear, and the yellowish green orange type one is called the mango. So we give this label beforehand, and this is the supervised learning form. I'm not going into unsupervised or whatever, but I told you what supervised machine learning is, and this is the first one what we're talking about. And supervised, what I said, it's just like what I said, training data and with labels, and we give that thing to the model. Now, we want the model to predict itself. So what we give is separate test data. Test data is something different from the training data. So you have training data, but you have testing data separately. Suppose I just give another piece of apple, but the apple's size is different. Maybe it's small, and the ones that were in the data set were big. But the machine learning had to learn everything because basically an apple has red color, the width and height and everything about it. So according to my previous training, it has to predict that my new picture of an apple that I give at the testing phase has to be a correct picture of the apple, where it has to respond with a test label and says it's apple. If it does, it's a success, and we did our machine learning process successfully. If it failed, then we would need more machine learning training and ultimately, trying to provide a better algorithm or other things. So that's basically the whole overview there. This basically notebook, what I'm presenting here, is an open source notebook that was provided by a book on machine learning, and the book is also available on the internet. It's, I guess, a very famous book, Intro to Machine Learning, whatever. But I'll leave down a link or whatever if I find it. But here what we have is the loading iris data and scikit-learn. Now, you might be asking, what do you mean by scikit-learn, right? What is this lingo? This is a package that is used in the Python programming language, which will we be doing for learning how to do machine learning algorithms. And scikit-learn provides a very easy way to perform, machine learning things. So this is the UCI learning repository, where this picture of a flower. Let me just give you the whole background here. Let me just quickly check in the chats to see if everyone's watching and everything. I think so far everything is going great. Uh, you guys could let me know in the chats if there's any problems or questions. Else I'll just keep moving forward. Just let me know if there's any problems or queries, so you could put them in the chats. Stream health, healthy stream settings. I think everything else is good. I think we're going great, right? Just give me a check mark or anything, Steven, or whoever's available. I might need some moderators maybe in the future events so I would know what's going on in the chats. Healthy stream settings. I think everything else is good. Okay, awesome. Thanks. Oh, thank you guys. Thank you. Okay, so there's this flower thingy, and now I'll give you the basic scenario here. There's this thing called this petal. And now this is a flower. It's a beautiful flower. It has four petals, and there's this sepal. I'm sorry if I'm mispronouncing it. I'm not sure how to say this, but sepal is something a part of a flower. It's the green thing what you see over here. This green thing over here. This green thing over here, and it's basically beneath the petal. And what happens is that when the flower blossoms, basically before it's covered by the sepals, and once it blossoms, the petals are on top and the sepal goes underneath. Now, what you want is the length of the petal. So that you can see this yellow petal. You want the length of it. You also want the width of it. You have the length of the sepal. Sorry about that. I just got a call. I had to. All right. So what we're gonna do is we have this length of the sepal, the width of the sepal, we have the length of the petal, the width of the petal, right? We have four different characteristics, four different features, right? So we provide these features to our training model. We're training, basically what we're trying to do is trying to determine whatever picture we give this model, and we have to know if it's three different types of flowers. So um, this is basically an iris. Iris is a type of a flower, and iris flower types. If I go in here, there's basically three important types. If I'm not sure, there's so many over here, but the three basic important ones are, I don't know if they're gonna give me, but this is the iris flower. Should be over here. Uh, Whatever. So over here, let me go back. Mm, yeah. So this is the iris flower petal sepal. Okay. So this is also in the Wikipedia. Um, and these are the different classes of the iris. It's one is called setosa, and one is versicolor, and the other is virginica. And what we're going to do is we're going to feed this image to our model, and we're going to determine our machine learning algorithm to know what type of flower it is based on the properties like length, width, and height, and everything. So that's pretty amazing. Now the features what I talked about was the length of the sepal, the width of the sepal, the length of the petal, and the width of the petal. And the target classes to predict are the setosa, the versicolor, or the virginica flower, the iris categories. So these are our classes. These are our features. Four different features, three different classes, and we're using machine learning for this. Now you might be asking, where did I get all of this data from, right? So this is taken from the UCI machine learning repository, which is basically open sourced, and it's basically provided with the iris or scikit-learn library. So for example, scikit-learn has a very straightforward set of data on these iris species. The data consists of the following. We already talked about this. And then there's this image, Wikipedia image, which is not loading, and we could totally ignore. So over here, what we have is the first line of our code. Now, you can see over here from sklearn.datasets import load iris. Now, before all of this, let me just maximize the screen so it's more easier to see. And I'm going to go from the first line. So I think everything is cleared here. You know the objective here and the drill. So first we're going to import our library. And I said we're going to have to import the sklearn library. This is scikit-learn. Scikit-learn is a library that is used for machine learning in Python. I thought I conveyed everything. And then we're using the package here. It's called datasets. And we import load iris. Now I told you there is datasets, and load iris is basically a dataset that is already built in the scikit-learn library, and we're using it, so it's pretty built in. You could just type it in on your own command prompt, and you'll see this load iris dataset appearing. So it's pretty amazing. Now what we're going to do is we're going to create an instance of this load iris. So we say load iris bracket a bunch. It saves it in a bunch object containing iris dataset and its attributes. Now you might be asking, like, what type of thing is a bunch? Well, bunch is containing. It's basically like a dictionary object containing a name and a value. So the name for it will be the feature name, and the value would be the value which is associated to it. Now I have notes that I prepared myself. So if you guys are interested, I would be providing these maybe on my Gumroad or whatever. But it turns like it is based on the demand if you guys are interested in these kind of things. So what we know is that there's this thing called the sklearn and everything, and I told about the feature name and the data. Now print the names of the four features. Now remember I told you that this bunch thing, this iris, is basically a bunch object. What I did is iris, and I said there's feature names. Let me just quickly type it in here. Okay, so what we have here is this iris has iris dot feature. I think we could also do it by tab maybe. So tab. Uh, so you can see over here what we have here, a lot of options, and then we have values. But what we're going to do is feature names, feature underscore names, and this is the first property of it. And the other one is the iris dot data, and you'll see both of them. But first of all, I'm just going to run this thing, this cell. To run this cell, you could simply press this run button here, and this is just running it. Or you could just go to the cell and then press Control and Enter, and this will also run it. And I think it's better because you're using your keyboard. The next cell, it says print the names of the four features. Like I told you, this iris object had two different properties. One was the feature name, and the other one was the data. Now if I look at the feature names, let me just quickly uncomment all of this, and you'll see that there's no result here on the bottom portion. But once I uncomment this, and now I see iris.feature names, like I told you, there are four different features. What were the features? The sepal length, the sepal width, the petal length, and the petal width. And this is going to be returned through an NumPy array, so it's a NumPy array. And you'll see over here, it's a list, and we have a sepal length, a sepal width, a petal length, petal width. Amazing. Um, the same thing goes for the data. So we have iris data, and what is this iris data? Well, this is the data that is provided for this, um, the flowers, and you could see over here. Now, like I told you, now this is a 2D array, and you might be asking, what is this so much? This is all provided in that library, and this is 5.1, 3.5, 1.4, 0.2. Now this is like the length, width, and everything. If I uncomment all of this, now you can see over here the length. The sepal length was 5.1. The sepal width was 3.5, all right, in centimeters. And then the petal length was 1.4. The petal width is 0.2. Now this data is basically entirely provided by our scikit-learn library. We basically imported it using the load iris, and then we just used it, and it was already built in the library. So it's pretty cool. We didn't even have to provide that data set. And you could provide data sets through Kaggle or anything. external websites. There are so many data sets, but I just used an internal data set that was provided in scikit-learn. Anyways, what we have here is this, and I hope you understood what this is. This is basically a 2D array and consists of so many values of objects. Uh, we'll think now this is a total of how many rows? I'll give you 150, and the number of columns will be so the number of columns will be 4. Why? Because over here we have uh, 4 different properties, so it's 1, 2, 3, 4. I believe there's one thing called shape or something, and then this gives you uh, the dimensions. So we have 150 rows of that data and 4 columns. I hope you got this shape command, and just press that enter back, and you'll see this thing. All right, so let's go. What's the next step? The next step here is printing the target names. Now print the encoding scheme for species. Now remember, like they're talking about species. Formally, just call it those types of flowers. One was the setosa, the versicolor, and the width. So remember, I told you the bigger the length, the smaller the width, or whatever the petal or the it'll be for what kind of a species of the iris flower. So Setosa is 0, versicolor is 1, and virginica is 2. Now this target names will basically contain the list of the different types of flowers. So Setosa, versicolor, and virginica, and by default, Setosa is set to 0, the value for it. Versicolor is set to 1, and virginica is set to 2. Now if I comment this one and I just show you the iris.target value. The target names were just the names, but the target is simply this entire list. And it's a list of the different types of flowers that exist here, and that's amazing. These are all flowers, and I believe there's a total of 150. And I guess there's maybe a count, but I guess it's not count. Uh, Maybe it's uh, mm, size. Yeah. So there's a total of 150 objects in here, uh, 150 different flowers, and 150 flowers, but different kinds of flowers. Some are setosa, some are versicolors, some are virginicas. And how I know this is because when I go back here and just show you the target, these are flowers basically. And what I told you is that zeros are identified by setosas, ones are identified by versicolors, and twos are identified by virginicas. And pretty amazing is that the first 50 are all setosas, and the next 50 are all versicolors, and the last 50 are all virginicas. So that's also one thing to note here. After that, we have the check the types and the features. Check the types of the features and response. Now, over here, what we have is iris.data, and then there's iris.target. Now, the thing here, what we have to do is check the types of the features and response. Just ignore that comment here, but I'll just tell you what this means. It's basically, remember what I told you is that what we had is target. Now, what is this type? This is actually a list, but formally this is we're using numpy, so we're using an array, and it's called an npy an nd array. So you say a numpy.nd array. So it's just telling what type of object it was for that the target. So that target is right here, and then the data which was provided earlier, this thing, with all those length, widths, and everything. This is also an nd array. Nd means n-dimensional, and this first one was a two-dimensional array which had an entire big list and then inside internal lists, and the second one was just a single 1D array. But the numpy just says nd array, so you just have to mean that they're n-dimensional. You could either say one-dimensional, two-dimensional, three-dimensional, but we know that the data one is two-dimensional, the target is one-dimensional. Next cell talks about the data shape. Now check the shape of the features. The first dimension, number of observations, second dimension, number of features. Now, first number of observations, and the second dimension, number of features. Okay, so the thing is, um, like I told you, this thing, which was the data, I think we did this already. I showed you that this is a bunch of iris.data was basically that 2D array that had so many lengths of the petals, the widths. One basic set. There was so many sets. There were like 50 of them. The first set of values had the width, length, width. It was basically for one flower, and then there was another set, and there was 50 of them. And what we did is basically told the shape. And then the shape is basically used to define the rows and the columns. So there were 50 of them, so there's 50 rows, but there were four different features, the four different columns. So that's why when we typed in data.shape, it gave us 150 and 4. But if we talk about the target was basically, um, if you view it, it was just simply the result, like the label. And 0 was meant for the first flower, the 1 was meant for versicolor or setosa or whatever. Everything is given up on the top, but this is just a one-dimensional array. So you might be asking, how many rows are there? Well, you could see this is actually 150 rows. There's going to be in different format. It's basically 150 rows. So all of these are just rows, one, one, one. It's not represented properly here, but when you look at it through that shape method, you'll see that it's 150 rows and the column is just one, and it doesn't give it, so it's by default one column and 150 rows. Okay, so now all of that is out of the way. We can finally train our model. Amazing. I'm super excited to this phase, and I'm looking forward. So I'm just quickly looking into the chat if there's any questions, and if I don't see anything, I'm going straight to this thing. So let's see. Oh, Status on is there. Hey man. Brianna Joe, awesome. All correct. Stephen Marsh, perfect. And we have pretty much doing great. Okay, so store feature matrix in X. Now what we have here is, mm, there's this X, capital X, and this is the matrix. And the matrix is basically used to include the data sets, and the Y is the response vector. And the data, like I said, we had two different phases. One was the training phase, and the other was the testing phase. The training phase had all the stuff that we used to, train our data with. So the data is basically the two-dimensional thing that we talked about, 150 rows and 4 columns. We push that all into this X, capital X, and we call it a matrix because the matrix is two-dimensional. It's basically more than one dimensional. That's why, and a vector is one-dimensional. So the target, remember the target that we showed, that was just, the zeros, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, and 2, 2, 2, 2. All of that is the target, and we put it in Y. So X and Y. Now, these are important because this is what we're going to be giving our model, X, and according to that, the corresponding label. So we say the data, the length width, and the response, the label, versicolor, setosa, or virginica, whatever that flower was. Okay, so all of that out of the way, and now we could start the matplotlib inline. So this is a command basically used to matplotlib is a library in Python, and inline is saying that we could use this matplotlib library inline in our Jupyter notebook. So we just type in this command. After that, we say import mglearn. Mglearn is also another library, and it's used to visualize something. So we say plot knn classification, and neighbors is equal to 5. Let me change this to neighbors is equal to 3, and let's just run it. Ignore this all red prompt, which is on the top, and you could see this beautiful looking graph that is generated through our model. Now this model is basically an algorithm, and this algorithm is called KNN. And KNN means K nearest neighbors. So there are different type of neighbors. There is this star middle on the in the middle portion, and this is orange color. And you can see the nearest neighbors are 3 over here, 1, 2, and 3. What we do is basically formulate whatever the nearest thing is. I know this is something that some people might use so much high complex words to explain, but I would try to say it in a very simple way. And it's very simple and easy to understand, easy to digest way. So you're just gonna love it. So what the thing is here is that we have this neighbor, which is 3. Neighbors at 3 means 3 nearest neighbors. Now this is a group of shapes you can see over here. This is a blue circle, a triangle. Now these are trainings, okay? Training. And remember test, prediction, test, prediction. Stars are the tests, the predictions that you give. So the training phase is over here. They're all scattered around circles and triangles. Now you can see over here the predictions that I gave. First prediction was this orange star, whatever, over here. And you can see over here the nearest neighbors were 3 because I gave it over here. N neighbors, number of neighbors is 3. The 3 nearest neighbors. And you can see that star, which had the prediction, has only 3. I only picked the 3 closest neighbors. So this one, and this one. Now you can see these two are orange, and this one is blue. So two of them are orange and one is blue. So the prediction should be orange because the number of neighbors uh, of orange are more than the number of neighbors which are close to the star blue. So that it makes sense. The two are orange, that's why it's orange, and one is blue, so we're not going to keep it blue. Over here, this is another prediction. So we have this star. The closest neighbors are three over here. This is one blue and two orange, so that means star prediction is orange. Over here, this is just dummy set, so this is not relevant to the data set right now, what we did, the flower one, but this is just completely giving an idea of what model we're going to be using, and it's called the KNN model algorithm, and we're going to be using this supervised machine learning algorithm, and I'm just explaining how this will work. So the prediction, what we do, we'll give it over here, and then there will be these three neighbors that we determine with. Now you can see over here, blue, 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 three blues. That means the star prediction is blue. Now you could change this up, and you could play it around, make it 5, and press enter. Now you'll see the 5 nearest neighbors. Now you can see that changed, and you can see now the star has 1, 2, 3, 4, and 5. Now two blues and three oranges. That means the orange star in the middle. Three oranges, one blue, and I mean two blues, so three oranges, and then this is entirely all blue. So you can just keep playing around and change it up. But I'm just going to keep it to 3, and I just wanted to let you know that, okay, for those of you who might have problems with running this, you might see this thing, but I would just recommend ignoring it. Um, there will be some people who might have problems running this cell, and I had this issue before, but I'll just let you know what I did. I basically imported the mglearn library, so maybe pip install mglearn inside of the Jupyter notebook, and just after that, reload your notebook, and it should work. Okay, so now after that, what we explained the machine learning model that we're going to be using. Now let's use it actual in our code, in our Python code. So what we're going to use is from sklearn.neighbors import kneighbors classifier, and this is the algorithm that we're using, the k nearest neighbors, but this is called kneighbors classifier, and from sklearn import metrics. Now these are the two libraries that we're going to be using, and sorry, not two libraries, but uh, two packages within that same library, which is sklearn. So one is metrics, and the other is the kneighbors classifier. So the kneighbors classifier will contain an input parameter, which is the nearest neighbors. And remember, I told you that it gives you 3. You could change it to 5, whatever, but I'm keeping it to 3, and I assign it to this KNN object. And once I do this, I could print that out, but I'm gonna train it. You know, like the training phase where I'm testing that model. I give it that x and that y. Now, what is x and y? I gave this before. Remember the x that I gave the data, all that two-dimensional array. You know, the length, width, and the y was the label that I said 0. So Setosa, 1 for versicolor or Virginica, right? 1 or 2. So those labels I gave, and the x. One important thing to note here is that I'm not making the model cram something. I'm not saying, I was not making a tabular form while it's saying for this set, this is the label. For this set, this is the label. This set, this is the flower. It's not like that. It's basically forming a pattern. And then after that, when you give another sampler as a test, it won't just give you 100% result. It will try to understand that pattern that it was generated, because this pattern is made here. Like you can see over here that there is the neighbors that were familiar with it. So the more the appropriate number of neighbors, like say the matching neighbors over here, we had two oranges. So that's why it changed its color to orange as well. So that's why it's not learning it. It's not actually cramming or root learning it, but it's actually formulating a result based on a saved pattern. I hope that made sense during that training phase. So it's basically training here, train, train, train. After that, we have ypred, knn predict. I commented all of this, and then there's this print score. So all we have to know is this score thing. And you can see over here that you could see that there's a 96%. But let me just rerun this to give you the result. Okay, so that it says name x is not defined. The reason this is happening is that because I didn't have all of these things running. So I think I did run this one. So I'm just going to rerun this. I'm going to run this again, and I'm going to run this again. So I'll just keep running. Okay, now x and y weren't run. So now they ran. Now, I think this was did run, but I'll just rerun it. And now I'm gonna run this. Okay, so now you can see 0.96. So this means 96% of our training is successful. So we just tested our score, and we use this metrics function here. And what we did is basically said um, a KNN score of X and Y, and it gave us a 96%. Okay, so one other thing that I wanted to address here is that this score is basically used because of that fitting and how much fitting has been done. So that is commented here. Let me just uncomment this part and this part out. So what happens here is that we have this KNN object that was trained. Suppose it's like a dumb object, but you trained it with so much that you know the 150 samples of flowers, and once you trained it, uh, what you want to say is that you say KNN.predict, and you say the X sample, and you want a Y prediction. So you're doing the same thing. You got the training data, you trained it with the same thing, but you're giving us during the testing phase, you give the same exact training data, if you know what I mean. I'm not using separate testing data. I'm using this exact same training data to retrain or retest, training, and then after that, suppose I'm giving an example of a human life. Suppose you're studying for an exam, and you have this a short question, and you're studying that short question, and when you go to the exam, that exact same short question appears, and you have to attempt it. Now you're basically that same short question appeared, so that means we're using that same training data, and now we're testing it with that same training data, and we're just determining how accurate our results got. Now the bot wouldn't just give it 100% all the time. I mean, it wouldn't be 100%. It's not possible because it's basically matching patterns. So what you'll see is that there will be something lower. So it gave us a Y prediction. Now we compare that Y prediction with our own Y prediction that we had. And where's this Y prediction? It was defined already here earlier. So we just compare it, and we use this accuracy score method, which is inside that metrics that we imported. So we print that up, and that was the 96 that we actually added. So this was the 96%. So it's not 100%. Crazy, right? Because it's the same thing. It should have been 100, but it's not. One trick here is that if I keep it 1, it will be 1, and this is 100%. But there's a reason behind that, is that basically it's not using the nearest neighbors, and there's a different problem there. So we're going to have to keep it with more neighbors so that the machine learning algorithm is uh, acceptable. One thing is not proficient, and it wouldn't give us any appropriate results for different data sets. So there's a whole type of explanation there, but I'm not going into detail. Now we're basically using splitting data into training and testing because we just tested it with the same exact training data that we gave. Like I said, we got a short question, we attempted it. I mean, we studied that short question the day before, and when we go to the exam, that same type of short question appeared, and we just tested it with that same training data that we gave. So that's not proficient. We want to do something even better. To do something even better, um, sorry about that. I should have kept my phone silent, but no problem. So now what we're gonna do, we're doing something even better. What we're gonna do is we're gonna split the training and testing. So we're splitting the training and the testing data. So some portion of it will be for the training purpose only, and some of the portion of the data, the remaining portion, will be used for testing. And we're not using the entire data for just training, and then the same exact data for testing. Suppose it's basically like 75% conventionally, you use it for training, and the 25% that's remaining is used for testing. For this process, we use sklearn, model selection, import, train test, split. This is all stuff that you won't want to know word by word. It's totally fine to just look at this notebook, keep going again and again, maybe rewatch this video to understand how this is working, and you'll get everything correct. So what happens is that we have this training and testing phase, and to make things more clear, I would like to open up Paint and show you just what happens. So the thing is, we have okay, so we have this file here, and then we have this data here. Now you might be asking, what is this stuff, man? This X was the data. Remember that data I gave, and then this was the Y data. What are you talking about? The X data, remember that big data that I gave? Um, you might be asking, like, what are you talking about? But the thing that I'm talking about is that the X, remember that capital X, the 2D array, the length, width, length, width, length, width, and then there were 150 of them, four different features. And then this Y was just the label, like it's a Setosa, it's a versicolor, and it just had like 0, 1, or 2, right? So now what we're doing is now we're splitting this. First, what we're doing was getting this whole thing and just training it with our model, entirely just train it with our model, and then we'll use the same train and test to just test it with it. So that's not a good approach. Now what we want to do is split our data set. So we're going to split it. You can see this, I split it. So 75% of this, so you can see 70%, 75, this is called the X train. So I'm just going to call this as X train. Ignore my writing, I'm sorry if it's bad. And then this other part, which is also 75%, and this is called the Y train. And this is the exact same stuff that I was talking about, but now we just splitted it. And this is just used for the training. And now the remaining 25% is going to be called what? This is going to be called X test underscore test. Okay, and then the remaining 25% for the Y will be called the Y test. So now that's what we're doing here. So how many variables do you think we have here? Oh, this is Y test, this is X test, this is X train, and this is Y train, 4 different variables. Go back to your notebook and you see over here, X train, X test, Y train, Y test. These are 4 different variables that are coming out from this train test split method that contains the X label, that contains the Y, that contains the stratify Y, ignore this for now, and the random state 40, and ignore that too. And what happens is that we have this 4 different variables. And now what we do is that we say can neighbors classifier, and we give it neighbors of 7. So why are we giving 7? Let's do something like 3, what we did. So I'm changing it to 3, and you will see over here, name train test split is not defined. Because I didn't run the first one, that's why. So now I just run that one, and then I run the second one. And then after that, what I do is can fit K train, X train, and Y train. Okay, so this is awesome. X train and Y train. And what we're doing in this fit part, can and fit, is what we're training. That train, like a ninja warrior, a kung fu panda. We're training it, and then we go for our testing phase. But before going there, I would just like to predict X test. So now we're basically going there into the testing phase. To go to the testing phase, what we do is knn.predict. This is our test. And what we do is we say the X test, the remaining X test that was here, and we say give us a Y prediction. Then we compare that Y prediction with Y that we already had. Uh, so Y prediction with the Y test that we already had. So that's why we had Y test was already given here, right here. So we already had it, so we just compare it with the metrics dot score accuracy underscore score, and it should give us some accuracy. Just to make this as 3 because I did the nearest neighbors to 3. Now let's check the accuracy of our X test variable. So to get our test, now let's see like the test results. Suppose I prepared everything for the quiz. Now I went to my exam, and what happens is that I take the exam, but I see that these questions are not the same one that I studied for. I mean, they're kind of the same, but the concepts are the same, but they're not exactly the same. The statements are not the same. And let's see what the result came. So it's like the iris things, but whatever now image you give, it'll give you an accuracy score. And there you go. We got a test score of 97%. Insane. This model is trained to 97% accuracy. So that means whatever image you give with a length width of a sepal and a petal, and you also just give that. You don't have to give any Y result. You don't have to give that label if it's either a setosa, a versicolor, or the other last one. And the machine learning model will automatically give you the result, whatever that flower is. It's a versicolor, or a setosa, or whatever, and it'll give you as a Y prediction. And then the Y prediction will be compared with the Y test that you had, and and this is the result that it gave. Amazing. Now let's look at the same case here, but we're looking at the training phase, and we're comparing that training. So prediction, we're just training, like, now look at the preparation phase. If we could compare that preparation phase with a Y prediction and just look at if the preparation data is good. So let me just rerun this, and let me just change this n minus 5 to 3, because we're using 3 nearest scenarios. Where you could do this for 5, you could do it for 7, you could do it for even more numbers. So now over here, for the training phase, when you were training, you had a 95% accuracy, which is mind blowing because you could see that the test results are better than our training results, which is insane. But this is something that we need to consider. Um, but that's something that we did about machine learning, and we created a model. We trained that model, we tested the model, and we showed our results. Let me know what you guys thought about this. This is like almost the end. I'm not going to cross validation and all that. Cross validation and all this extra stuff might be for maybe future. Turns out if you guys had that demand. But if you have any questions so far about this session or anything in general, just let me know. I might be concluding it afterwards. So just give me all your questions and I'll be asking it. And just let me know what you thought about this session. Was it something interesting? Was it something that you learned new? Was it something very good? I'd love to hear your responses. So I'm going back to the chat. And let's see what you guys had. Okay. Stephen Marsh? hmm hmm And let's see what you guys had. Okay. Stephen Marsh? hmm hmm And let's see what you guys had. Okay. Stephen Marsh? hmm hmm And let's see what you guys had. All right, so Stephen, let me know what your questions are. Or anyone else, whoever has questions, just let me know. I'm in the chat. Just waiting for your responses if you got something. I am lost on line 8. Which line 8? Let me see. The chart. Oh, that, let me see. Line 8, line 8. Are you talking about this model over here, this chart? I don't know which line is it. Oh, line 8. Is this the thing what you're trying to say? Line 8 over here. Um, the load iris or something. Um, because this recording will be provided, could you explain what that is showing in terms of the data a little slower? Um, you know what I would recommend? I would recommend joining the Discord server. And from there, you could ask me a little. Maybe I could invite you for a small voice call or something, and we could discuss it, really quickly. So join the server. This is a link to the server. Just sending it again. Oh, you sent some code. Okay. Link to the server. Okay, you're saying mglearn.plots, plot canon, class. Oh, okay, 5. I got it. Okay, so that part of the that code, if I could bring it up again, canon classifier. Okay, this is basically, like I said, we're basically providing a dummy of the algorithm that we're going to be using. We're using canon classification. This is an algorithm. It's a supervised machine learning algorithm that we're going to be using for our machine learning model to determine whether that flower is a setosa, a versicolor, or a virginica. So to do all of that, we use this algorithm, and this is called the KNN, and KNN means K nearest neighbors. Now, this thing over here is just a plot of how the algorithm works, and I use neighbors as 3, meaning the 3 nearest neighbors. Now, this star here is just the prediction, and these other things, the shapes like triangle, and these circles are just our training stuff. So training class. So what we do here is that we have this prediction, prediction, and prediction. So I had this orange prediction, and you could see over here k nearest neighbors meant 3. So this is a dummy. Like this is not going to be uh, affect the model that we have, but this is just a way to explain it. And then when we actually use it is over here in this part after the chart. So when we import scikit-learn sklearn.neighbors import k nearest neighbor, k neighbors classified. When we do that, then we actually use it. But here I just gave it as a chart to show what the explanation is. So what happens is that we have this prediction, like this orange star, and then you can see that the neighbors, the three the most closest neighbors are these three. There's nothing that's more closer, and that's more far, and that's farther. That's just how it goes. So these are the three nearest neighbors. You see that the colors for these two are orange, and this one is blue. So the majority is orange. So that's why our prediction should be orange. Then after that over here, this other prediction here, we have the three closest ones are these three. You can see these two are orange and this one's blue. Now, because these are majority in orange, 2 is in majority, so that's why our prediction must be orange. That's why over here in blue we have the majority as 3 blue, and that's why our prediction is also blue. That's how this algorithm would work. It would look at nearest neighbors, so that's why the data basically is mapped out in dots like all of this, scattered around, and then these are your predictions. And according to what your the length and the length to the nearest neighbor is, you basically use that as your baseline to predict that result. So I hope that made sense. And this is how it's used to predict whether it's an orange or it's a blue, or whether in real terms it's a setosa, it's a versicolor, or a virginica. Using this, algorithm, I basically explained it a very high level way so that you could understand. I'm not going into that much complexity. So, any other questions? Uh, in real terms, it's a setosa, it's a versicolor, or a virginica. Using this, algorithm, I basically explained it a very high level way so that you could understand. I'm not going into that much complexity. Any other questions? Any other questions before I conclude this set? Uh, in real terms, it's a setosa, it's a versicolor, or a virginica. Using this, I know my voices are repeating, so I'm just gonna have to leave that. That did clear it up. Awesome. Thanks, Steven. Uh, great. Is there anyone who else has questions, or we should, conclude this? Let me know what you guys thought about the session. You could leave your responses in the chat as well. Um, join the Discord server. Follow Coding Cleverly on YouTube. You could check out the chapter page on Codecademy. There's so many places to learn coding, and I believe Coding Cleverly is one awesome resource to have. So um, try to be a member. Maybe if you really want to support Coding Clever, then I always recommend becoming a patron. So becoming a patron will really uh, you know be awesome. So here's the Patreon page. All you got to do is go to there and you can become a supporter, a backer, or investor, and you'll be unlocking some exclusive content that I have there. Um, so yeah, it's always a treat. Yeah, thank you guys. Awesome. Here's the Patreon page. So Patreon page to support Coding Cleverly. Thank you guys. Appreciate it. Have a great day. Keep coding, and you know, see you next time. Thank you guys. Bye bye. Peace out. Let me just close this live stream now. So end stream. End.